For today's notes, we're going to piggyback off of what we finished up discussing in the previous notes. When you look at a chemical reaction, you're going to be given reactants and products, and you can think of them as if they are the ingredients in a recipe and your end product or your yield. So let's go ahead and look at some problems dealing with this equation where we take hydrogen and oxygen gas and make water. Number one, how many moles of water can be made if 6 moles of hydrogen gas are used with unlimited oxygen gas? So what that's telling us is that the oxygen gas is not going to limit our equation. The only thing that will be limiting it is our 6 moles of hydrogen gas. In our equation, it says that typically we have 2 moles of hydrogen gas, and in the end we make 2 moles of water. So that's a 2 to 2, or if you reduce that, a 1 to 1 ratio. This question you could probably answer without setting up a proportion. If you have 6 moles of hydrogen gas, since typically you use the same amount of hydrogen gas to make the same amount of water, you know that then you would make 6 moles of water. The other way you can do this is actually to set up a proportion. You take the coefficients from the 2 items from your equation that you would like to use, set them equal to each other in a proportion like so, and then take the amount from your question and put that on top of the coefficient in the reaction. So this side has my hydrogen and this side has my water. We're going to solve for the moles of water in this proportion, and when you do that, I showed you that you can just cross multiply the one item to get your x alone. You would have 6 times 2 or 12 divided by the denominator of 2, which gives you 6 moles. All right. Next question. How many grams of water would that represent? You need to remind yourself that we have the mole calculation on the back of your reference tables that says that moles is equal to your given mass divided by your GFM. This time we have our moles of water, so that will go here, and we can always calculate the GFM of something if we have the formula. The formula for water is H2O. H is 1.01, but we have 2 of them, so we're going to multiply that by 2, and you have 2.02, plus the mass of oxygen, which is 16, so that works out to be 18.02. So now we can plug our numbers in. We have 6 moles of water is equal to, we're trying to find out what that mass is, divided by the 18.02 grams per mole. Again, you can put this over 1. We're trying to get G alone, so we really only need to cross multiply this side. So 18.02 times 6 will be our answer, and that is 108.12 grams. Next question, how many moles of oxygen are required to make 150 moles of water? So this time our proportion is going to involve oxygen and water, so we'll put those coefficients on the bottom. This side being for the oxygen, this side being for the water. We are looking for the moles of oxygen, so that's where I'm going to put my X, and we were given 150 moles of water. Don't really have to do anything to get rid of this 1, so really all I need to do is do 150 divided by 2, which is 75. And we solve for moles of oxygen. All right, these next questions are going to be based on this equation here. We have two different reactants and we have two different products. So there's lots of variations of questions we could ask with this. Number 4 says there's only 59.64 moles of the ammonia, this is the ammonia here, available, and how many moles of nitrogen oxide, which is the NO here, can be produced. So this time we're going to be dealing with the ammonia coefficient and the nitrogen 2 oxide coefficient. So the coefficient on ammonia is 4. Coefficient on the nitrogen 2 oxide is 4. So this side is my ammonia. This side is my NO. We have from our question that we have 59.64 moles. It's kind of a weird number. We're going to solve for nitrogen. And actually, since these two cancel out, the answer is going to be 59.64 moles of NO. Next question. How many grams of water can be made using 192 grams of hydrogen gas? For this one, I would suggest, and you can do this each time you do it, the hardest thing we can do is ask you to do 3 steps in your equation. The first step would be going from grams to moles. We can't compare grams of water to grams of oxygen. Our proportion is based on number of moles or number of molecules, and the masses are going to be different depending on the GFM of the substance. So we have to convert the mass to moles before we can compare our moles to our moles, which would be the next portion of the question. So you're going to go from the moles of the oxygen to the moles of the water. But the question is asking for grams of water. So the last thing we're going to do is we're going to take our moles of water that we figured out in the second step and convert that to grams. This is the absolute hardest thing that we could ask you to do. In the question above, all we did was go from moles of ammonia to moles of nitrogen oxide, which is just this step. You will always have to do that second step. It's that first or third one that you may not have to do. So the first one, we need to get to moles of oxygen gas. So we're going to use our moles equation. Moles is equal to G over GFM. The mass we were given was 192.0. And then we just need to use the GFM of O2. Oxygen is 16. 2 of them would be 32. 192 divided by 32 is 6. And now we have our moles of oxygen. Now we can use our proportion. This time we are going to be talking about oxygen and water. Here's our oxygen, here's our water. So our coefficient on oxygen is 5. Coefficient on water is 6. So this side is going to be my oxygen. This side is going to be my water. So I'm solving for the water. I figured out my oxygen right here. So I'm going to put that here. And now we just have to do the math. Again, all you really need to do is this. When you cross multiply, 6 times 6, 36 divided by 5. And I got 7.2 moles. And what I've just done is figured out the moles of the water. So whichever side has the X on it, that's going to give you what you just figured out the moles of there. If my question were only asking for moles, I'd be done, but it's asking for grams, And we know that we can use the moles equation again to convert from moles to grams. So now we can plug in our moles of water, 7.2. We're looking for grams, and we figured out the GFM earlier for water to be 18.02. And now all we have to do to solve, we're just going to multiply this times that. You can kind of imagine that's over 1, and you get 129.74 grams of water. And that's the hardest thing that could be asked of you in a moles and equations question.